Okay, in this video I'm going to do a very quick introduction into translational, rotational, and then a combination of the two, translational and rotational speed. So, if I have an object and it's moving at a translational speed, translation means that it's just dragging along, it's not spinning, okay? I could take that object, let's make it yellow here, and if I showed the velocity vectors for that, all of the lines would be going at the same speed because it's just moving in translation. So I took this and let's say I'm going to clone these. Okay, all of these will be moving at the same speed. The whole object just moves across like this. It all just moves like that at the same. So all points of the object are moving at the same speed. Alright, so now let's just say that I took a wheel and I'm going to spin that wheel on its axis like this, right? So I'm going to take a wheel and I'm going to spin it. Just pretend like it's not on the ground, it's just spinning in place like this. So I'm going to put an axis here like this, and let's just pretend like I'm going to give this some type of an angular speed like this, omega. It's going to spin like that. So what does the tangential velocity profile look like? Well, it's going to vary as you get further away from the radius. It's going to increase. It's going to be 0 right at the radius, and it's going to be a linear profile like this. So if I drew those arrows again, what this would look like is it would slowly decrease as you went in. So I'll draw it in by hand here. So the velocity profile of a spinning wheel, it's not on the ground, it's just spinning in the air, okay, would look like this. I would have these velocity profile arrows. I'm going to draw them in red just to clarify them. I would have them going across like this. There's a maximum tangential speed as I get away, and then as I get towards the center, okay, it's going to get smaller and smaller. As I reach the center, there's no tangential speed, and then as I get away like this, okay, I'm going to increase once again further away. So this speed is just going to be some function of r omega, and omega is the angular speed. Okay. Now, what happens if we have both of them together? Well, if I have both of them together, I'm going to get something like this. I'm going to draw them in two parts here. Say that I had a wheel that had all translational speed. Let's say that I had a wheel here that was exactly as this one. So I'm going to move this down here like this. So let's say that I had one that's being dragged, and I want to know the velocity profile of that dragged object. Well, that translational profile is just going to look like this, right? It's going to be the same the whole way down, just like we saw before. Okay, just like with the block. So if I took these two profiles and I added them together, okay, in other words, if I have an object that's spinning and it's moving at the same time, now I have rolling motion without slipping, okay, because let's just go back for a second here. This is just dragging, right? And this is just spinning in place. But what if I spin and I move along the surface now? Okay, so I get a new profile from that, and that's going to look like this. It's going to be kind of cool. We take a look at it. What's going to happen is basically we're going to get a simple linear superposition. These two velocities are going to add up, and believe it or not, these are actually the same, so they're going to be double on the top, and then these are going to subtract on the bottom. You see how that's going that way and that's going that way in the opposite direction? So these are going to cancel out. These are going to double up at the top. So here's how this looks. It's kind of crazy. Okay, so here you have a speed of 0 at the ground. You have a speed of 0. And then out here, you're going to get a speed that's actually double of this one. It's both of these added up. Okay, so your speed now is going to be looking like this. Let me just get one more line here just to show down the center. Going straight up like this. So your speed, by combining these two, is actually going to look like this. Isn't that kind of crazy? So this is purely the translational. This is purely the rotational. and this is going to be the combination of both of them. For an object that's rolling without slipping, okay, when I say without slipping, it means that the velocity at the ground is 0. So that means that when we solve these problems, that point right there is not moving. So we're going to use static friction, believe it or not, when we solve these problems. Okay, so this is not the case of a bowling ball that's slipping as it's sliding, right? This is gripped to the ground and it's just moving and rolling together. So we combine these two. So just to review again, let me just put a couple numbers here just to simplify this. Let's say that this had 1 meter per second everywhere along here, right? And let's say that this had 1 meter per second everywhere along, or at the top here, excuse me, just at the top, and then it gets smaller and smaller and smaller. It's 0 in the center, and this is negative 1 meters per second, like this. Okay, and the bottom here is still 1 meter per second on the translation. So you can see how 1 plus 1 on the top is going to give me 2 meters per second on the top. At the bottom, when I get 1 to the right, 1 to the left, right, or negative 1, I'm going to have a speed of 0 meters per second on the bottom. If I looked at the center, right, this one still is 1 meter per second, right, here. This one's 0, right, so 1 plus 0 is just going to give me 1, so right in the center I'm going to have 1 meter per second. Okay, and that's what the profile looks like of rolling. Okay, so this is rolling with no slipping. Okay, and so that's what it looks like. It's important to conceptualize this because first we need to see an object just as it's moving translationally. Okay, it can be a block. I could have also just dragged a circle across, right, or a cylinder. What does an object look like when it's just rotating? And then we would say, what do the two of them look like together when they're rolling?